and we're going to break 6.2 down into 2 lessons. 6.2 deals with 3 types of identities: sum identities, difference identities, and double angle identities. We're going to be looking today at the sum and difference identities. So basically, the objectives say, once I tell you what the sum and difference identities are, we're going to be applying them to solve math problems. And this is going to also eventually involve doing what we have been doing, but with new identities. Instead of looking for just Pythagorean or quotient or reciprocal identities, you're going to be looking for these. So what are they? Well, it turns out, and I can verify this, and I don't want to do this with every one. If you have sine of a plus b, and we use the Greek letters alpha and beta, but you could write a and b. A person who knows nothing about math or has not been taught this before might believe that if you have the sine of the sum of 2 angles, that you can take the sine of the first angle and add the sine of the second angle. But it just doesn't work that way. Okay? It's like me saying to you, if I have 2 things added and I'm squaring them, can I do this? And the answer is no, you can't do that either. There's a different rule for how you do that. Well, the rule for how we do sine of a plus b, and it looks, by the way, you can verify this. You could put 30 degrees here and 20 degrees here, and you can take the sine of 50 and then try taking the sine of 30 and adding it to the sine of 20. It will not give you the same thing. Okay? So it turns out that the sine of the sum, this is called a sum identity, is equal to the sine of the first multiplied by the cos of the second plus the cos of the first multiplied by the sine of the second. Now, I'm going to show you 6 identities here. And even though some of them are going to become so familiar to you that you're confident you know what they are in doing your work, I would highly recommend just double checking at least to begin with, because it's easy to mix them up. The difference identity, the sine of alpha minus beta, is just like the sum identity, but there's a subtraction sign in between. And by the way, before I talk about the second identity, the order in which you subtract these 2 things is important. Subtraction is what I would call an order-sensitive operation. You have to subtract them in that order. So the sine of alpha minus beta is sine of alpha cos of beta minus cos of alpha sine of beta. The sum identity for cosine is entirely different. The sum identity for cosine says the cosine of alpha plus beta is cos alpha cos beta plus sine alpha sine beta. Got it right. So there's a lot that's different here. With the cosine identity, you have 2 cosines multiplied together and then the 2 sines. But the other thing is, for the sum identity, you're subtracting, and then the difference identity, you're adding. So the cosine of A minus B is cos A cos B plus sine A sine B. And I'll tell you right now, every time we have to use the sum or difference identity for tangent, I have to look it up. I often confuse these 2 identities, which I couldn't tell you what they are until I look at them, with the double angle identities, which we'll learn about next week. So I would have said something different. The tangent of A plus B is tan A plus tan B over 1 minus the product of tan A tan B. And then we have this identity for the difference, identity for tangent. And don't look at this going, oh man, I'm confused because shouldn't some light be going on in my head that this all makes sense? No, this is not going to all make sense. I'm telling you we have these formulas, and they're on your formula sheet. But they're called identities because they're always true as long as the angles or the variables are permissible. So let's take a look at some questions. Write each expression as a single trigonometric function. This would not be a multiple choice question even, or a numerical response question. It might be part of a bigger problem on an exam. What you're going to do is look for a pattern. You're going to go to your formula sheet, and I would recommend having your formula sheet out here, because you could just look at the top of the page 8, 11. Top of page 11 and look at them there, but we're going to turn the page in your handout shortly and that will be gone. So you should have your formula sheet in front of you. You're looking for an identity that matches this pattern, that has the sine of an angle times the cosine of an angle minus the cosine of the first angle times the sine of the second. And you should recognize that the identity that does that is sine of A cos of B minus cos of A sine of B is equal to sine of A minus B. I will flip back and forth between using the letters of the regular alphabet, A and B, and using alpha and beta. But that's the identity, correct? It matches? Okay. Well, then that just means that this is equal to sine of 42 degrees minus 19 degrees. So our answer is sine of, help me out here, 23? Thank you, 23 degrees. And we're not going to do this, but if you were to use your calculator and find sine of 23 degrees, it would be some weird decimal. I don't know what it is. Doesn't matter. 0.2, 0.3, whatever. You can work it out. If you were to take sine of 42 times cos of 19 minus cos of 42 times sine of 19, you would get the same result. The immediate question that pops into some students' heads is, so why would we even write this? Well, in higher math, we're going to encounter applications where you end up with that expression, and it isn't that you write it that other way. You stumble on that long expression, and you write it in a simpler way. I'm just using square brackets because my round brackets get all fuzzy on this program for large brackets. You're looking here for an identity that has cosine of an angle, different angle, minus sine of the two angles multiplied together. Sine of the angles times sine of the angle. And that is cos alpha cos beta minus sine alpha sine beta equals cosine of alpha plus beta. Am I right? Okay. So all that means is that this is going to be cosine of 2 pi over 3 plus pi over 3. Well, that's cosine of pi. 2 pi over 3 plus 1 pi over 3. 2 kittens plus 1 kitten is 3 kittens. 2 pi over 3 plus 1 pi over 3 is 3 pi over 3, which is pi. So this is cosine of pi. And at this level, you should certainly know that that's equal to -1 without using your calculator. I'm thinking a unit circle kind of approach here, that at pi radians, we're talking about the terminal arm lying along the negative x-axis. So it's going to intersect the unit circle at -1, and cosine is the x-coordinate. All right. Determine the exact value. Now we're into an exam kind of question. 7 pi over 12 is not one of those angles that we have intimate knowledge of the coordinates on the unit circle. If it was pi over 3, I know the coordinates at pi over 3 are 1/2 comma root 3 over 2. If it was 3 pi over 4, and if you're watching this on video, you can't see my arm, but if this was 3 pi over 4, I know the coordinates are negative root 2 over 2, comma, positive root 2 over 2. I have knowledge of those specific numbers. 7 pi over 12 is not an angle that we're familiar with the coordinates of. Let's figure out what 7 pi over 12 is equal to in degrees because we think better in degrees. The work in radians is often easier to do, but in this case, let's think in terms of degrees. And I'm just thinking here that pi radians is 180 degrees. So I just have to take 7 times 180 divided by 12. This is going to be 7 times 180 over 12. I think that's 105 degrees. So what that means is that cosine of 7 pi over 12 is the same as cosine of 105 degrees. And 105 degrees it's on the unit circle. It's there. We just don't know what the coordinates are. By the way, if we did know what the coordinates were, we would be looking for the x-coordinate at this point. In fact, if this were just a earlier kind of question, cosine of 105 degrees, the x-coordinate is this number, okay? But we want an exact value. This is not a rational number. We can't convert it to a fraction. So how do we do this? What we do is we look for two angles that we are familiar with on the unit circle that either add or subtract to give 105. And given that this angle ends in 5 degrees, 45 degrees is going to be one of them. 60 and 45 would do it. So cosine of 105 degrees is exactly the same then as cosine of 60 degrees plus 45 degrees as a quantity. Well, don't forget, you can't just take the cos of 60 plus the cos of 45. Trig doesn't work that way. But we do have an identity for cosine of a sum. This is the cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. And we do know what the cosine of 60 degrees is, or we should be able to determine it. And I admit I'm quicker at this than most of you because I've been doing this for a very long time. But when you take a look at 60 degrees, I don't even want to show that to you. I mean, you should be able to draw this out and say 60 degrees is here. On the unit circle, the x-coordinate is a half. Right? I mean, I think we've kind of graduated away from me showing this to you every time. You should know where these numbers come from. So, cosine of 60 is 1/2. Don't forget that this, it's going to get a little crowded here, but that's okay. You don't have to write this down. We're talking x-coordinates here on the unit circle because it's cosine. And when you go to 45 degrees, that's root 2 over 2 for an x-coordinate. Now we have minus I just want to line things up here. Minus sine of 60. Well, that's the y-coordinate at 60, which is root 3 over 2, multiplied by the sine of 45, which is also root 2 over 2. If we clean this up, here we've got two fractions that are being multiplied, so we multiply across the top, giving us root 2. We multiply across the bottom, giving us 4. So we get root 2 over 4, minus, we multiply across the top here, and we get root 6. That's a math 20 idea, actually a math 10 idea. When you multiply radicals, you can multiply the radicands, the numbers under the radical sign, over 4. And then you have two fractions. You can only add fractions if they have a common denominator. And we caught a break here because they do have the same denominator. So what we end up with is root 2 minus root 6 all over 4. And there's nothing you can do with root 2 minus root 6. That's like having x minus y. It is what it is. Hey, you know, we can check this now before I finish off my discussion of this problem by taking the square root of 2, closing the brackets on the argument, subtracting the square root of 6, and then dividing that result by 4, and we get that same number that we got when we just said, what's the cosine of 105? For that reason, this would never, I don't think, be a multiple choice question, because you could just take your calculator and figure out what it is and then go through your choices. This is a perfect example of a numerical response question, though, where the stem of the question says the cosine of 7 pi over 12, that's what it was, wasn't it? Yeah. Is equal to root A minus root B all over C. What are the values of A, B, and C? And the answer is 2, 6, 4. And I don't know if you recall, but in the last trig unit, I talked about there are ways to weasel and maneuver your way around not knowing these numbers. But you can't do that anymore. Okay. Tan of 165. We're going to do the same thing here. We're going to find two angles that add or subtract to give 165. And those angles have to be, 30s, 45s, 60s, multiples of those. I think it's always the case when you see these questions that the angle you're dealing with ends in 5 degrees, which means one of the angles is going to be 45. 45 plus 120. Now, tangent is a little more complicated to get values of from the unit circle, but we're going to see in a second that it's not that bad. Now we need to go to the sum identity for tangent, and I don't remember what it is. Is it on the top tan A plus tan B? So this will be tan of 45 degrees plus tan of 120 degrees. On the bottom, is it 1 plus tan tan? Minus, thank you. And we could do these problems all day, and I'm always going to be unsure of the tangent ones. 1 minus tangent of 45, tangent of 120. Now, I'll remind you that tangent of an angle on the unit circle is the y-coordinate over the x-coordinate. So it's more complicated than just writing in x or y coordinates. But at 45 degrees, y is root 2 over 2, and so is x. In fact, how many of you knew that tangent of 45 was 1? You don't, I mean, on a written response, maybe you might have to demonstrate that. But we're going to get 1 here because y and x at 45 degrees are the same. This is going to really simplify things in this identity. We're going to have 1 plus whatever the tan of 120 is over 1 minus 1 times whatever the tan of 120 is. So now on the side, I'm going to figure out what tangent of 120 degrees is. Well, that's y over x. And at 120 degrees, I'll show the unit circle portion to you in a second, but I'm just going to demonstrate this with my arm. At 120 degrees, y is root 3 over 2, and x is negative 1/2. So we're going to have root 3 over 2 over negative 1/2. Whenever I see a student write a fraction with that slanted line, I say don't do that. I'm just doing that because I've run out of room here. Okay. If I multiply the top and the bottom of that by 2, I get root 3 over negative 1, which means tangent of 120 degrees is negative root 3. And I'm going to put that negative root 3 here. I don't really need the brackets, but I'm just putting it there to indicate I'm doing a substitution of tangent. And what I end up with is 1 minus root 3 over 1 plus root 3. We're not going to do this on the calculator, but if you took tangent of 165, yeah, and then you figured out what 1 minus root 3 in brackets divided by 1 plus root 3 in brackets was, you'd get the same thing. Again, for a numerical response, I know that A and C are the same, okay? And I know that B and D are the same. But I don't think you would ever see this. You might. I mean, you might see that and just ask for A and B. I think, and I'm going to put A, B, C, and D there just to remind you that they don't all have to be different numbers. Your answer here would be 1, 3, 1, 3. Any questions with either of those? All right, we have a couple more before we turn the page. Simplify this expression. Well, this is like what we were talking about before. You're standing in the middle of the road and you want to get somewhere. You're not going to get somewhere by just looking at it. This is about identities, so let's use an identity and apply the identity to this. The cosine of A minus B is cosine of A, cosine of B. I don't need brackets around the x, or the pi over 2 for that matter, plus sine of A, sine of B. So I'm going to ask everybody to think on this just for a second now. Well, first of all, are we okay with that move? The identity is correct? Okay, I'm going to ask everybody to ponder this for a minute. What would we do now? How is this remotely helpful? And now that you've had a few seconds to think about it, I'm going to ask my kind of always question. How many of you see that this is equal to sine of x? The reason is, this is 1. Nope, this is 0. My mistake. At pi over 2 on the unit circle, the x-coordinate is 0. This is 1. I mean, you should know those quadrantal values on the unit circle, those values of x and y at 0, at pi over 2, at pi, at 3 pi over 2, at 2 pi, on and on and on. So what we're left with is 0 times cosine of x, which is nothing, and then 1 times sine of x, so this is sine of x. It's like we did a question, Janessa and I, this morning that looked incredibly complicated. It was the one with sine to the 4. And I mean, I had no idea where it was going. But we did one thing and a little bit of algebra, and it became very clear what it collapsed into. We did one thing here, and it turns into sine of x. This is equal to sine of x. And by the way, this is actually an identity that you might see on a formula sheet at a higher level. Let's try another one similar to this. What is tan of pi plus x? Okay. I think I got this one for the identity. It's tan of pi plus tan of x over 1 minus tan of pi tan of x. Yes? Did I get it? And the only reason I got it is we just had the same identity in the previous question. So what is tan of pi? Well, pi on the unit circle is here, and the coordinates are -1, 0, and tangent of a rotation angle is y over x. I feel as though I have to say this, and we're going to have this problem in the very next example as well, that this x here and this x here, it's the rotation angle that it refers to. this x refers to this number, right? So in tan of x on the left-hand side, x is the rotation angle. So what is the tangent of pi? Well, it's y, which is 0, over x, which is -1. Oh, we caught a break again, and this often happens with these problems. Tan of pi is nothing. So what are we left with? We're left with 0 plus tan of x over 1 minus 0 times tan of x. Well, that's tan of x over 1. It's tan of x. On the bottom, we just get 1 minus 0, which is 1. All right, let's turn the page. And this is a beast of a question, not in terms of all of the work. Each individual piece is pretty basic, but there's so much of it, and we also have to grapple with something. Let's read this together. Cosine of x is equal to 5 over 13. Tan of y is equal to 4 over 3. We're told information about where angle x and angle y exist. But here's the issue we have to get around, okay? That cosine is x over r. Tangent is y over x. But the x's and y's I've just written in green are not the x's and y's given in the question. Right? This x right here, this x and this y are rotation angles, not coordinates. So we have to keep that straight. And I'm not going to do this, but if you have an exam question like this, I'm just going to do it up here and then I'm going to go back to what we're looking at. If you have an exam question like this, it might be beneficial for you to just rewrite it that way. Do you catch my meaning here? I'm going to keep the x's and y's though. And I thought I had set this up, there we go, so that this was printed, but it's not printed on your handout, is it? Let's take a minute and just make a chart here, because what we are going to need to do is for angle x deal with the x coordinate, the y coordinate, and the value of r. And for angle y, we're going to have to deal with the x coordinate, the y coordinate, and the value of r, the arm length. And what we're going to do here, this is trig unit A stuff. For angle x, coordinate x is 5 and r is 13. Finding the value of y, the coordinate y for angle x, should be child's play. We'll get to that in a second. For angle y, y is 4 and x is 3. Is that correct? I kind of am misleading you a little bit here because I've ignored part of the question, haven't I? Angle y is in quadrant 3. And in quadrant 3, x and y are both negative. That's that hidden pair of negatives that we often see in tangent. And finding r for angle y should be child's play as well. So we have to determine this number and we have to determine this number. Let me explain why. How come? if we want to figure out what sine of x plus y is, we have to say it's sine of x cosine of y plus cosine of x sine of y. We have to use an identity. And I'm about to write some stuff down that I don't know that you need to write down, but you might. This is y over r for angle x. This is x over r for angle y. Let's unpack this, because boy, that's tricky. Why is this first part y over r? Because it's the sine of an angle. Why is it for angle x? Because it's the sine of angle x. Then I have x over r. Why is it x over r? Because that's a cosine. Cosine of angle y, so we have to look at x over r for angle y. This, we're going to have a plus in here. This will be x over r because it's a cosine, but it will be for angle x. This will be y over r because it's a sine, and it will be for angle y. I'm using kind of really awkward notation here and abbreviation. Had I rethought this, I would have spread it out more and written them out with words. But do you get my meaning here? Okay, so what makes you successful or not in a question like this is your organization. There's a lot to think about. Can everybody please use x squared plus y squared here? To confirm that you get r equals 5. In fact, how many of you just know r equals 5 when you have the 3 and the 4? Okay. Can we all please, does anybody know that this number will be 12? You've remembered that? Okay. This will be x squared plus y squared equals 13 squared. When you do your work here and take 13 squared minus 5 squared, you get 144, and you take the square root of it, but it will be plus or minus the square root. And the question says angle x is in quadrant 4, and in quadrant 4, y is negative. So now we have to put all of this stuff in here, and I want to keep this on the same screen, so if you were writing this down, I think you've already written it down. I'm just going to get rid of this. Sine, I'm looking at angle x is negative 12 over 13 times cos. I'm looking at angle y, which is negative 5 over, which is negative 3 over 5. And each of those is a trig unit A question. Cosine of angle x is x over r. Sine of angle y is y over r. Just want to double check all that. That's a sine, that's a cosine, that's a cosine, and that's a sine. So the fact that I'm not struggling is the wrong word. I'm being very cautious here. It tells you that you need to be very cautious as well. I know that you could cancel these 5s, but let's consider the fact that we're going to have fractions. If we leave the denominators alone, we'll get a common denominator. This is going to be over 65, because 13 times 5 is 65. We get 36 over 65 minus 20 over 65, which gives us 16 over 65. Now, as I go through B and C, I'm going to be asking for your help in confirming the numbers that I believe I'm dealing with for x, y, and r, for angle x and angle r. But any questions about A? Right? So, how are we going to do B? It's the same thing, isn't it? Now I've changed something in your note package, so can you confirm that B is the same as what I have up here? Okay, it's the same thing, it's just that we're going to be using a different identity. This will be cos of angle x, cos of angle y, plus sine of angle x, sine of angle y. So cosine of angle x, I just want to put here that this is an x over an r, this is an x over an r, this is a y over r, this is a y over r. Because the first two pieces are cosines, they're both x over r. The second two pieces are sines, they're y over r's. Can you confirm that cosine of angle x is 3 over 5 by looking at your table for the angle x side? So the x coordinate over r for angle x is 3 over 5. No? Oh, I got them backwards. Is 5 over 13? Correct? Okay, sorry, I've got them backwards. Can you confirm that cosine of angle y is negative, I better look, I was going to get it right anyway, negative 3 over 5. Okay, negative 3 over 5. And then we're looking at angle x again, but this time we are going y over r. Did I get my y over r correct for angle x? Multiplied by, thank you, multiplied by my y over r for angle y. Did I get that correct? Okay, so now it's just simplifying this. And you know, I know some of you want to just throw it into your calculator. Be careful, because you're dealing with fractions, so your entries need to be done properly. I'm going to just do it on paper. I get negative 15 over 65, plus I get 48 over 65. I think that works out to 33 over 65. So the cosine of x minus y is 33 over 65. And just because why not, let's do one with tangent. Tan of x plus y will be tan of x plus tan of y over 1 minus tan x tan y. First question for you, is that correct? Did I get that identity correct in my head? Okay, good. And you're always looking at your formula sheet. You're not challenging yourself. You want to make sure you get things right. So I want to remind you that this will be y over x, this will be a y over x, this will be a y over x, this will be a y over x. But the y and x that we choose has to be found by looking at the right angle. So y over x for angle x is negative 12 over 5. I'm going to work left to right here. I don't normally like to do that, but negative 12 over 5 plus tan of y, well, that was 4/3. We were actually given that. If you want to write negative 4 over negative 3, you can, but it's 4 over 3. I just sense a little hesitation in some of you right now. Is this correct so far? So we look at angle x, and we take the y over the x for angle x, negative 12 over 13. I'm pretty sure that's right. For the y over x for angle y, we take the y over the x, which is negative 4 over negative 3, which is 4 over 3. On the bottom, we have 1 minus the negative 12/5 times, oh, I see what the hesitation was. I wrote 4/5. That's what you guys were balking at. I get it. 4/3. Never feel afraid to tell me that, okay? Does that look okay now? Okay, so now we have to clean it up. You know, if I were really worried here about algebra, I would say we need to multiply top and bottom by whatever is necessary to eliminate the fractions. This is just the numerical answer. Nobody cares how you get the final answer here. I would use my calculator to calculate the top and the bottom. So we have negative 12/5 plus 4/3. This is the top. I'm going to divide that by the bottom, which is 1 plus 48/15. I don't know what's wrong with me, why I keep writing 65. 3 times 5 is 15. And then convert it to a fraction, because why not? Negative 16/63. Three more to go, but this is lightning quick, these last three. Look at this one. First of all, note the change. I want you to change that to a minus. Secant of any quantity is the same as 1 divided by the cosine of the same quantity. Well, that means the reciprocal. And in one of these questions, we found the cos of x minus y, didn't we? Didn't we find it to be 33/65? So that means this is 65/33. So if you're ever given a question like this that said, what is the secant of x minus y? Find the cosine of x minus y the way we did, and then flip your answer over. Similarly, I think in question A, didn't we find the sine of x plus y? Okay. Well, this is the reciprocal. I'm just going to write this different way. It's the reciprocal of sine of x plus y. Well, sine of x plus y was equal to, Lynette, what was sine equal to? Negative 16/65? Just 16/65. Well, that means that this is equal to the reciprocal, which is 65/16. And cotangent of x plus y would be the reciprocal of tangent of x plus y, and tangent of x plus y we found to be negative 16/63. So we take the reciprocal of it. This goes way back to Unit 1 when we had just cosine of an angle, and then you were asked using x and y and r to find secant of the angle. You just flipped it over. On page, I have a feeling my page numbers are going to be wrong. I think we're going to have to add 2 to each of these numbers. No. 3. I think it's 13 and 14, is that right? On page 13 and 14, those are the assigned problems. And I will double check here, but I believe this is going to be starting on page 27. That's correct. These are supplemental problems. So these are extra practice ones. We are only spending one day on this, so we're not going to have time tomorrow to work on these. If you want to work on them, you can. The ones that are not assigned here are ones that involve proofs that we'll learn about next week.